place, and it requires a fair bit of explaining. So I've made a bit of a list up here of things I need to go through. This is going to be one of our harder problems. So the first thing is, what do we mean by tangent? Because I've been throwing that word around to you, and I haven't really explained it properly. So a tangent is a line that is parallel to the curve at a particular point. So what that means, if this is a circle, and if you were to zoom in on that circle, right, and you keep zooming in, eventually it's going to look like a straight line. Okay, so an example might be, planet Earth from outer space looks spherical, but if you zoom in on it, to us, it looks like it's flat. Okay, that's because we're really, really close to it. And so, like this whiteboard is parallel to the Earth. Okay, but if you could shoot a light beam in that direction, it's going to go into outer space eventually, because the Earth curves away from it. All right, and so that's what a tangent is. It's a light beam that's parallel at a particular point. That's what we mean by tangent. Okay, so what we're going to perform here is what's called a proof by contradiction. So this is quite different from the other proofs, because the other proofs we've been starting with something we know to be true, and then rearranging it and discovering something else that is also true. Okay, so we're starting with a truth, and then we're coming up with other truths. What we're going to do today is we're going to start with a premise that we don't know if it's true or not. And then we're going to see what does it lead to if we assume it's true. And we're going to see it leads to some absurdities, it leads to something that's impossible, and therefore it can't be true. So probably what I'm going to do, I'm going to do the proof on this board, and then I'm going to do some explaining on this board. Okay, so most of the proof's going to be here, and I'm going to be coming back over here to explain certain parts of it. So we're going to start with our circle. I might make it a fair bit bigger because there we go. And then here is our tangent. Okay, and we've got the centre of the circle O, and let's put some points on here. We can have A, B, and C. So what we have in this circle is we have line AC is tangent. Okay, this is the tangent to this circle. Touching at point B. Now we're trying to prove that it's 90 degrees, and I've said we're going to prove this by contradiction. So that means what we're going to do is we're going to assume this angle, OBC, is not 90 degrees. Okay? So looking at it, it looks like it's 90, and that's never enough justification for us to make an argument, just because it looks like it. Things are never drawn to scale. So we have to have some other evidence. So we're going to assume angle OBC is not 90 degrees. This is our starting premise. This is our false premise. We're going to assume this, and then we're going to see what absurdities it leads to. Because this angle, it's either 90 degrees or it's not. Okay? If it's not 90 degrees, it could be anything else. But they're the only two possibilities. It's either 90 degrees or not. So we're going to assume it's not. Alright? And so what that means, so I'm going to come up over here, do some explaining. If I have a point and a line, okay, and I could say if this angle in here is not 90 degrees, okay, that line connecting the point and this line, if that's not 90 degrees, there exists somewhere else on this line a point that will be 90 degrees. Okay, there exists somewhere else along here a perpendicular line. So the same applies here. If this angle is not 90 degrees, and I understand it looks like it is, but we're going to try and stretch our minds over here. If this is not 90 degrees, there exists somewhere else a point that is going to be 90 degrees. So I am going to exaggerate a bit. Let's put it over here, and let's call it, what are we up to? A, B, C, D. And so we've got this point here. And so this is what we're going to assume. This angle is not 90. So we're going to say this one is angle BDO is 90 degrees. Okay. Doesn't look like it. We've got to stretch our minds a bit. So if this angle is 90 degrees, let's have a right angle triangle, okay? If this angle is 90 degrees, and I'm going to say this angle is 40 degrees, what's this angle have to be? 50, okay? If this angle is 1 degree, what's this angle going to be? 89 degrees. Okay, it doesn't matter how many times we keep doing this, both of these angles are always going to be less than 90 degrees. Okay? So what that means for us over here, if this angle is 90 degrees, let's put the 90 there, we're assuming that's 90. If this angle is 90 degrees, it means this angle here, OBD, has to be less than 90 degrees. Okay? Alright, fine so far. We're saying this angle, if this is 90, then both other angles have to be less than 90, which means this angle also has to be less than 90. Now we've defined BDO as 90 degrees. So if angle OBD is less than 90, it means angle OBD must be less than angle BDO. Okay, so let's not get confused between less than and angles. Alright? So we've got this angle is less than 90, this angle is 90, so this angle has to be smaller than this angle. Doesn't look like it, but it does have to be. Okay, some more explaining. If we have a triangle drawn like this, okay, if this is a small angle, it means its opposite side is going to be small. If we have a big angle, it means the opposite side is going to be big. And so that means the angle dictates the length of the side. Okay, this angle tells you how big this side is going to be. And so angles are going to preserve that ratio with their sides. And so if this angle is less than this angle, it means the side opposite to this angle is less than the side opposite to this angle. So what that means is OD, okay, remember this is angle OBD, so OD must be less than, here's angle BDO, the side opposite it, OB. OD must be less than OB. Alright, so let's just elaborate that part a little bit, because that's probably, I think, the crux of it, that's the tricky part. We've said angle dictates the side. Okay, so we've got a small angle, we've got a small side. Here we have this angle is smaller than this angle. So what it means is this side must be smaller than this side. Okay, let's put another point here, let's call it E. So OD is OE plus ED. Okay, I think here we can see the problem. Alright? Is that OB and OE are equal to one another because they're radii. So let's make that statement. And so what that means for our expression here is that OB, I'm going to substitute OB in there because they're equal to one another. OB plus ED is less than OB. And we can subtract OB from both sides. And so we've got ED is less than 0. Okay, here's our contradiction. ED is a length. This is a length. It can't be less than 0. And so because we started with this false premise that this angle's not 90, that there is some 90-degree angle elsewhere, it's led us to these absurdities where there's some length that's less than 0. This can't be true, which means this premise is not true. We assumed it's not 90. We said there's only two possibilities. Either it's 90 or it's not. We've shown that if it's not 90, impossible. So therefore it must be 90. So that's going to be our argument. Therefore angle OBD equals 90 degrees. I should probably add a bit more here. This is impossible. So therefore our assumption was false. Therefore the opposite of the assumption is true. That's a proof by contradiction. So this is your only proof by contradiction that you'll do. It's a good introduction to it. I think it makes a lot of sense, but obviously there's no way you'd be able to formulate that yourself. So, okay, that's all I wanted to go through today. So we're just going to continue with, I think we're up to question 10, okay, of the circle stuff. So let's proceed with that. See how we go.